Live.
It's live.
Hey, welcome everyone. This is Ratina, co-founder at Crio.do. As part of the Art of Product Building series, we have a special guest with us today, Dhaval Nagar. Dhaval is an expert in DevOps, and especially is an AWS expert. I think last 3 weeks, we have talked about how to think about requirements deeply as a good product engineer. Then we touched upon high-level design and low-level design fundamentals. And we also talked about last week about coding best practices, how to think about unit testing and integration testing. Now we are in the fourth session talking about deployment, right? I think Dhaval is the best person to do that. Thanks a lot, Dhaval, for being here and sharing your expertise with our audience.
Thank you, Rathina, for the opportunity.
I think without taking too much time, I think I let Dhaval introduce himself and actually get started with the masterclass on deployment, specifically focusing on building evolvable systems on AWS. Over to you, Dhaval.
Great, thank you. First of all, welcome everyone. I know might be a very busy week and plus a lot of other things going around us. So in this particular, first of all, I would like to thank Crio and Rathina for giving me the opportunity to talk about AWS, and we'll explore how AWS can help in the problems or the use cases that you have taken to actually deploy your solution onto the cloud environment. So without spending much of our time, we'll start with the session. So this session is regarding building evolvable system on AWS. Myself, I am currently I have quite an experience on AWS. Been using it for years now. I also run AWS user group in my city, Surat. Also Serverless Hero since 2020. It's last year. I'm also AWS certification SME. I have done quite a few certification. I have also contributed into certification process as well. And I also run a small development consulting firm. We are also AWS consulting partner. So that's a little bit about me. So overall, we are going to look at why we should use cloud. You will find kind of a huge amount of information, huge amount of news, and quite common usage of the word the cloud. Everything is cloud based. Even the system that we are using right now, that's also nothing but because of the cloud that we are able to actually use it and connect with each other. So why we should use cloud to solve the modern problems. Next, we'll look at the usage of AWS. What is Amazon Web Service? What exactly consists of Amazon Web Services? We'll then explore the use cases that is part of your kind of externship program that is designed by Crio, and we'll see how some of those use cases can be kind of achieved using the Amazon Web Services. And along the way, we'll also see that how we should actually design and architect our system so that it can evolve. I'm taking a very simple approach of we have an idea, we need to think like a startup, and we need to solve this particular problem like a startup. So why use cloud? I mean, we have been hearing about this for many years now, right? And now is the best time, especially after the major disruption of the last year. A lot of companies, a lot of enterprises are actually moving to the cloud, and startups have been using the cloud computing for years, mainly because if I align that with the kind of Crio extension program as well, they have given a set of problems, right? These are the use cases. The same way a startup is basically found around solving a particular use case. They want to launch something which is faster, which can be actually put together, solving the right problem. At the same time, you do not want to spend a lot of effort, energy on building the raw stuff, and also not spend a lot of money. So these are some of the core kind of a principle that I consider when we are designing the new age solution. So I want to actually launch something very fast, want to just focus onto the problem itself instead of focusing on other things. I want to iterate faster, and I want to actually fail fast so that I can actually come up with a new use cases, the variations and stuff like that. Focus on the feature engineering. I want to solve the problem. Even if you look at the overall use cases that is given to you, they all talk about the problem, and they are not talking about the what kind of infrastructure you use, what kind of technology that you use. You just need to solve the problem, okay? And the problem can be solved in a variety of ways, but ultimately the problem, uh, the right solution is something which can scale, which is secure, and which is also kind of cost effective. So keep the cost minimum. That's in the mind of everyone, and especially onto the startup. So the overall approach that I am going to take throughout this particular session is that we have a bunch of problems. We want to solve it. We want to solve it using the cloud computing, cloud services, Amazon Web Services. At the same time, we want to also leverage the true kind of agility and the other features of cloud computing. So why use cloud? I mean, AWS is not fundamentally the technology-oriented company years back, but they are the leader in the cloud computing for almost 10 years, 10 plus years now. So this particular kind of a graph is taken from Gartner last year. I'm not exaggerating, but they are in the leader of infrastructure and in other space for a long time. And there are many other cloud providers as well. And Amazon has been doing this for over 1 decade or almost. The first service just last week celebrated a 15-year into production, that is Amazon S3. Amazon has a wide variety of services, almost multiple services to actually solve different kind of use cases. Some of the most popular services that they have is RDS, that's for the relational database, DynamoDB for the NoSQL database, Lambda for the serverless computing, S3 for the web-based storage, SageMaker for the machine learning. And we'll look at some of these services going in the upcoming slides. So that the overall at the outside, the overall cloud is divided into the simple kind of pillars. You have the compute where you actually host your code. You have the storage where you actually keep your data, your files. You have the networking, how you integrate, how you connect everything together. And you have the security, how you actually protect your overall environment. Inside it, the overall cloud, AWS in general has many services, and they actually are divided into different segments, different area. If you see at the bottom, we have the regions, availability zone, and point of presence. These are the physical, the presence of the data center of AWS. And we have the networking part, which is on the left side, how we actually reach to the cloud if you want to connect to the cloud service. And inside we have the software as a service, some of which are infrastructure as a services, some of which are software as a service, some of which are platform as a services, and some of which are just Lambda function as a service. So overall, there are 175 plus services. I don't remember the exact count. Different document actually represent a different count, but somewhere around 175 plus services are there, major services are there, and AWS contains some of the largest number of services when it comes to the cloud computing. So before we jump onto the AWS side, as I mentioned, it's vast, lot of services. But at the same time, we are focusing on a particular problem that is given to us, right? Irrespective of which problem that you have selected, it's one problem that you want to solve. And at the same time, you have this big, giant kind of infrastructure given to you. We still need to make sure that we think like a startup. We select the right services. We use it in the right way, in responsible way. That's why every time, even personally, when I design the solution, I map it with what exactly that I'm trying to achieve with the solution, and use the right services for that. So with more power comes more responsibility. With just a simple credit card, I have the full AWS account for me, but that doesn't mean I go inside and start using every single thing, even though it is not required. So AWS is quite vast, but focus on what exactly that you need. Like the problem statement, start with a simple, start something very small and build incrementally. And that's how we look at how we can actually design the evolvable system. If I take a very simple example of hosting your code, the first thing that comes into our mind is basically a virtual machine. Everyone needs virtual machine, right? You need to host your code somewhere. The simplest way you can host your code is actually just create a virtual machine and then SSH inside that, download your code and start using it. But then at the same time, depending on the use case that we are trying to solve, uh, whether we are selecting the right virtual machine, do we really need a virtual machine which will run 24/7? Can we stop it? Can we start it? Question like that. If we are talking about the configurations, what will be the size of the disk that we need? Do we start with 100 GB or we can start with something small? These are not the same question that we ask for every use case, but I'm just giving an example that when we are actually selecting the infrastructure, we need to also understand that whatever that we are creating, that is sufficient for our use case to begin with, or are we actually kind of considering it future possibility and using it, trying to create it or use it like that now. So as an example, I find a lot of people confused when it comes to the instance virtual machines. So virtual machines nowadays are much more different compared to they used to be a few years back, where it was a very simple selection that, okay, I need 2 core, I need 4 core, I need 8 core, I need 50 GB or 100 GB, and that's, but nowadays, because cloud is growing, they host some of the most complicated workloads. Every workload requires something very different from depending on the use case. Some requires more CPU, some requires more RAM, some requires GPUs, and some requires a very different kind of storage and networking, those kind of things. So this is something that actually I tell everyone that if you are using AWS, be familiar with how the underlying compute works. It's a very simple graph. We are not going to go into the detail, but I'm just putting this here as an abstraction, or just to understand that when it comes to hosting the code or using the virtual machine inside the AWS, there are many parameters on which the selection of the virtual machine is taken care of. And this is something which will be very hard exercise when we are actually starting something small and something simple on the AWS. And that's why selecting and configuring the right infrastructure is hard part. We should start with something small, something simple, so that we can actually grow when our application grows, or when actually our solution grows. But otherwise, we should still understand that what exactly that we are selecting. Then this is the right place to actually then introduce that why we are going into those kind of things, why we are saying that AWS has so many choices, even the compute has so many choices, and we should actually select the right compute. The evolutionary design is a practice of growing a system in a natural way, by adding the minimum amount of code to actually satisfy the business need. In an iterative and incremental approach. When done right, the code structure changes continuously to optimize for change, thus allowing a constant speed of development for a longer period of time. That is, we are actually not putting everything at the same time. If you are, let's say you are designing a chatbot, then you'll first look at what exactly that you will use as an underlying framework to have a conversation. What exactly the conversations are centered around, so that you are only focusing on that idea. If you are designing an IoT based application, then you'll focus on what exactly is the nature of this IoT. How frequently the IoT device is going to send the data. What exactly is going to be the size of the payload. If you are designing the web or the mobile app, you will also pay a lot of attention to the interactions, right? And then decide that what kind of data that you will get in, what kind of a backend computation that you are going to take. Out of those whole thing, you first focus on the most critical, right? The must-have. These are the features that you need immediately, and then nice to have. These are the features that you add once your basic features are there. The most simple example that comes to my mind, I've been actually programming for almost 15 years, and over the years, the most simple thing that comes to our mind is the user authentication part, right? every system that we actually start with, the first thing is we need people to actually sign up. We need people to log in, and we need to actually make sure that we have the right session so that they can interact. So that's kind of a first piece that we need to kind of design. But if we are designing something which is backend or processing intensive, then we just only validate whether our algorithm works or not. If our algorithm works, whether it takes the right input and gives the right output, then let me start actually adding the other layers around it. It's kind of an iterative approach. I start with something which is kind of a core and focus of the overall solution, and then I start building other things around that. Some of the key things here is designing the system or building the software or writing the code in a natural way. Write something which is necessary first to validate whether everything that you are thinking that works right or not. Minimum amount of code. You do not want to write 1,000 lines of code just to prove simple things. Iterative and incremental. It's not going to be you are not going to write the whole code in a single way. So you need to still write it in a way that you can actually add more features along the way without finding it very difficult to actually expand the system. So the way that we are going to actually look at the AWS services here is that when we are solving the problem, even in your problem statement, I have gone through some of the problem statements that is presented by the Crio. So it says that this is the problem and this is what you need to come up with a solution. It doesn't say that this is the infrastructure that you need to use. This is the kind of a platform or the technology that you need to use. This is the language that you should use. It is only focusing on the problem. Now the cloud or AWS has matured so much that there are huge number of services, and what we are going forward is that there are many layers in which these services are structured. The one is that the whole platform is provided as a service. In that case, the underlying hardware or underlying infrastructure is basically abstracted. We do not need to worry about what kind of server is used underneath, what kind of operating system is kind of used. All we need to do is, okay, I am looking for MySQL database, and when I create the database cluster or database instance, I'll get a kind of an endpoint where I'll connect the database. I want to actually host my HTML, CSS, and JavaScript, and I'll get a URL. If I click on the URL, it should basically load my web app. I want to actually create an API proxy so that when I create it and I hit that API, it should basically invoke my code. So this is an abstraction part, wherein which the underlying infrastructure, the underlying the other things, the operating system and the other things are basically hidden, and we are only using the service for our use case. So in next few slides, we will actually look at what all services that the AWS provides with respect to our use case. So the overall idea is to own less and build more. This is something that I have taken from one of the a very popular person in the serverless community, that is Forrest Brazil. Has written this popular article on A Cloud Group, where fundamentally we are actually trying to solve the problem by just focusing onto the problem itself and not onto the infrastructure. Use the right service with the right configurations. Do we really need virtual machines running 24/7? That's like we just need to focus on the problem, not the infrastructure part, not reinventing the wheel. As I gave an example of user authentication, every single application that we design, one or another way requires some kind of a user identity kind of mapping, making sure it is secure and stuff like that. So do we really need to code, or can we use existing identity service and integrate into our application? Always monitoring the cost and users. Whatever that we are designing and building, make sure that it can scale, it can perform. At the same time, we are still paying for what we use. We are not paying something which we are not using. So what I'll do is, along this the way I'll actually go in the AWS console as well, just to see a few things, and towards the end I have a small demo as well. So here I have presented two screenshots. AWS has I think some of you might be familiar AWS has this. If you are actually signing up, you can actually have a free tier for the first year, where some of the services are having some kind of a usage which comes as a part of the free tier. So as much as possible, you can actually use this free tier and try to solve or accommodate your use case or your software in that. At the same time, if you are consuming some of the services which are not part of the free tier, or if you think that maybe your solution may consume something that's out of that limit, provided limit, free tier limit, AWS has a service called AWS budget. You can simply just configure your budget. This is because all the AWS accounts, I'm not sure if you have received the credit or if you have the free account, but it's still good to know that what exactly that you are consuming, whatever software or whatever that you are running, whether what kind of a service that it is consuming, and how much every component and service is consuming. It's just a simple dashboard. You can go inside, configure your budget, and it will actually start tracking that. And when it reaches to a certain threshold, it will actually start sending you notification. This is something I actually tell everyone to actually start first. You should always supervise how your application is performing from the overall execution point of view and from the cost point of view as well. It's kind of a startup mindset. You're solving the problem with the right mindset. So enough kind of a talk around the same things. Now let's explore one by one. We'll actually go through some of the use cases that is given to you, and we'll see that how we can actually map those things from the deployment and the usage point of view to AWS Cloud. First of all, very general, designing the web application, right? I mean, many of the solutions that I saw, one or another way, it actually leads to developing a web application or web app in the modern way. So which kind of services that the AWS has, how we can actually host the web application into the AWS cloud, and how we can utilize various things that we look at next. So a normal web application consists of some basic building blocks. We have the web server, we have the application server. The reason why I have actually taken the web server and application server separate is when I say web server is only basically kind of hosting my web assets, HTML, CSS, and JavaScript, something which will run in the browser. If you are designing the modern web application, you most likely are using some of the single page application approach, which actually runs the full front end into the browser. And the application server is something that which actually provides the API endpoint, and you interact with the system via the APIs, JSON based REST, maybe using the WebSocket or even the GraphQL. But that's the application layer part where you are interacting that via the APIs. So that's why I have taken web and application server separately. There are a few applications in which you can actually combine the two together. You can actually design the PHP based or Ruby on Rails based, where everything is kind of same. But here, for the purpose of the overall demonstration, I'm actually considering the two separate. Then comes the most important, authentication, which is, as I gave an example, authentication, the user identity, sign up, forget password, two-factor authentication, or even logging in with your kind of phone number and OTP is now very common. Most of the applications that you use every single day, you have one or another kind of an identity that you need to carry. Database, I'm just generalizing the database, but nowadays even the databases are having many variations, not just an SQL database. You can have SQL, you have NoSQL, you have the time series database, you have the graph database, or depending on the application, you might have even the ledger database. So there are many different form database that your application can use. Storage, in terms of the file or the media that you are actually receiving from the users, or the application is having its own file storage which you want to maintain, and outbound communications, mainly towards the push notification, email, and SMS. So these are some of the general kind of area for a web application, and many of these are basically applicable to other kind of applications, like for the mobile applications, or even some of these are applicable to even IoT based or chat application as well, chatbot as well. So this, let's consider this as a required that you want, And then along the way, you have some kind of an optional or kind of a side feature as well, which every application is expected, right? In a hidden way. You want your application to be secure. If it is the user based, you do not want that one user can see the data of other users or start actually manipulating those. At the same time, you want all of those data in a secure way. You want to scale as well. Your idea is working fine, your solution is also working fine, and you want to actually scale it if the demand of the usage rises. And scaling is not just upward scaling, even the downward scaling in some cases. If it is not actively used, you want some way to actually then shrink it. So by scaling, it's an elastic way. You want to grow, you want to accommodate all the usage based on the demand, based on the consumption. You want to also kind of reduce the usage of your infrastructure or the services if there is not much of a application usage. And that is directly related to the high availability and the cost effectiveness. High availability is, you want, whenever you hit the URL, you want your application to be there serving. At the same time, you don't want to overly pay just to keep your application working. So if you start mapping this one by one, and now I'll also explain why I have put web server in a separate category compared to application server. So the first thing comes is, if I'm designing a web application, irrespective of what language that I've used, the first thing that comes into my mind is I need a virtual machine. I need a machine in which I can actually host this particular port. It will have the DNS, or it will have an IP address where I can go and start using it. So do I need, the first biggest question is just for the web, HTML, CSS, and JavaScript, hosting those things. Do I really need a virtual machine? The data transfer out, that is everything that comes out of the instance. In most of the cases, if you use AWS or if you use any of the other cloud provider, it is paid because you are actually downloading the data one by one. The operations, additional operations like the operating system task, maintenance, installing the right libraries, tools, all those things is something that becomes part of your responsibility. Now, when we talk about the startups and we are talk about just focusing on the idea and implementing that, we do not want to spend time on making sure that we have selected the right operating system. We should know what exactly is the library, the tools, and the other things that we need to install and maintain those. That's the place where we have a mapping service in the AWS that's called Amazon S3, which is generally known as a storage service, elastic, high scale, almost kind of infinite storage as a service. It has one feature in which you can actually statically host your assets, HTML, CSS, and JavaScript. It's called static web hosting. This is the part where you do not want the intensive compute. All you want to do is you want to actually save your asset somewhere. It generates a URL, and that URL the browser can refer and actually download. So this is the part we are using a virtual machine, which is the full compute layer. We are allocating the CPU, RAM, and disk just to serve the web assets, which is going to do maximum of the work onto the browser side. Okay, the only point where we require that is when we hit the URL. All other cases, it will be actually doing most of the work into the browser side. So that's where the service like Amazon S3 comes into the picture. It works as a kind of a storage and the CDN and the hosting as well. It's highly scalable because we are not maintaining anything. It's fully serverless and cost effective. If you are storing, let's say, 5 MB of data, it will be just counted as a 5 MB. If you are not using it, nothing will be counted when it comes to accessing your data. It's only the storage that you are actually paying for. No additional maintenance because there is nothing kind of visible. It is like a Google Drive or a Dropbox where you're just kind of copy and pasting your files, and it generates a URL, and that's it. So there is no underlying infrastructure that is visible. You do not need to worry about how you will, what kind of disk that you need to actually allocate, and how you map that data with some kind of a web server like that. And it can host almost every kind of asset. So HTML, CSS, JavaScript is a basic example when it comes to the web application. But let's say you are showing the images, you are showing the videos, you are playing the audio. All of those things can also be hosted onto the S3 as well. So it's kind of one example that how we can shift from virtual machine to the storage services and CDN, where our purpose is very limited. The next is an application server part. Again, the same thing. I have detached the front end with the backend. So my backend is only serving the APIs. It is using the REST or GraphQL. It's just serving the JSON. Do I need the whole virtual machine to be 24/7 available? What kind of configuration do I need? Because I know that compared to my front-end layer, my back-end layer will be doing intensive work. It will be coordinating with a database as well. It will be executing some kind of business logic as well. So the configuration, it's kind of a decision that we need to take. What exactly will be the configuration that we need when we start? Do we need to run it 24/7? If you are just developing and testing, do we need to continuously run it? What happens if suddenly a lot of people start using it? You are sending out the invite, you are sending out it to the people to try out, and they come back and say that I tried, but it's very slow, or in some cases when I tried it wasn't responding. So all of those things will come and you need to start you need to look at what went wrong, whether it's fully running or not. If something went down, you need to go inside and start and stuff like that. So it's kind of an operation part that you are going into along with actually solving the problem. Now, if you look at the counter side, we have here I'm actually talking about serverless services. There are many other services that can also be used, but I'm taking a very simple example that how I can actually host the code and kind of run it when there is requirement to run it. So in serverless way. So API gateway becomes my front proxy. You can consider, if you are familiar with the web server, you can consider that as an Nginx or just a plain web server, HTTP web server, which is taking in the request. It's not doing anything. It's just taking in the request. And you have created a mapping that whenever this request comes, execute my this function code. Whenever this request comes, execute my this function code. It's kind of building the web server where every path is pointing to a controller logic that, okay, whenever this particular path request comes, I want to execute this. Whenever this particular path request comes, I want to execute that. But here we are breaking down into kind of a smaller functions, and overall we are designing the microservices. One endpoint is basically going to execute one piece of code. Both the API gateway and Lambda are serverless, very popular in the serverless category from AWS. Both can scale from 0 to thousands of requests without any additional effort because they are designed that way. There's no additional maintenance. Again, the same kind of structure because there is no visibility. We are just designing. I mean, these are purpose-built services. API gateway is designed to actually create the API endpoint. So the only interface that it gives is you can create your endpoint and attach what exactly that you want to execute. Lambda is designed different way. You just need to upload the function code and it will attach the trigger and it will execute. So there is no, the underlying infrastructure or underlying mechanics is not visible. It's only the configuration that is kind of available. API gateway, I mean, when it comes to the protocol, API gateway supports HTTP, REST, and WebSocket. So it can actually support a wide variety of application from the front end point of view. Lambda can support about half a dozen different languages along with the container, which is most recent addition. So it can overall it can actually solve a lot of different use cases without going into this full virtual machine base. And here also we are limiting. We are only focusing on our solution with respect to the problem, not the underlying infrastructure and the engineering part that we need. The next and a very simple kind of a use case is the authentication. Now, I mean, personally, I have designed the authentication myself many times. Like I said, I've been kind of a programming for many years. And early on, whenever we are designing any kind of an application, the one thing that we repeatedly do is that we actually put in the same, we are using the Java, we are using the Node.js, JavaScript, then we have some kind of a basic library or code that we copy and paste and then paste that one. But we are spending our time into something which is repetitive, which is same, which is not going to change, and more or less we may actually kind of do some kind of mistake into that. So the simple question that now I always ask is that, do we need to write the custom authentication by ourselves? Can't we use something existing? The Amazon AWS has its own services, but let's say if you are not even using AWS, there are many other services. Simple example is integrating the Google sign into our application. But even if we need to do that, we need to still manage some of the part on our own. So here we are actually offloading, we are transferring the full control. Instead of designing anything, we'll just use an existing service. And I have actually demo towards the end where I'm also going to showcase some of the capabilities of Cognito as well. Fully managed user authentication service, or you can say identity as a service. Nowadays, everything is as a service, so this falls into the identity as a service. Manages some of the very basic, starting from very basic to very advanced identity related integration or features like sign up, sign in, MFA, password policy, the tokens, even the integration with the enterprise systems, integration with a third party services like Facebook, Apple, Google. It can actually do a variety of things when it comes to the identity part. UI can be customized. It actually comes with an inbuilt UI as well. So we do not need to design our own UI as well. We can use the drop-in UI, customize it, and our authentication layer is up and running. It supports event triggers. Event trigger, I'll come next, and that's the point where we'll actually start going into the extensible and evolvable architecture. But it supports this service actually emits the events. We can use those events and customize our authentication logic if we want to do that. The next is in the web application category is a database. Where and how we'll store the data. As long as I remember, and many of the people that I know who actually spend a lot of time on their own ideas, most of the time they actually tend to use something very simple which they can download and start and use it locally, like MySQL or Postgres. Or many of the people that I actually interact in last few years, they use database as a service, DB as a service, like Firebase. Or if you have been designing or developing application for long enough, then you would have heard a platform like Parse, which actually Facebook acquired and then shut down. It was very popular, and it was actually doing the whole, it was providing the whole database backend as a service. So database installation, I'm not a DBA, but it's not a simple task. Installing, selecting the right version, installing, maintaining that, making sure that it runs always. It's a tedious part. If I am focusing on to just solving the right problem, I don't want to go into the tasks which are specifically or very non-trivial, which requires some kind of an additional learning and understanding from the database point of view. Needless to mention that we are still talking about only a specific kind of a database, like in SQL, MySQL, or in NoSQL, maybe MongoDB. But if you want to use something for a graph DB, you want to use something related to a time series database, you want to use the caching, then you need to actually start maintaining those things separately and spending some additional time on that. Again, the bigger question is, do you need all these services running 24/7? This particular slide is not going to help on that, but you still need to kind of operate those, make sure that those are operational 24/7. These are those are very initial features, and you will most likely set up, install, and even run it. But at the same time, there are a lot of things that we lose because we tell ourselves that we do not need the monitoring from day one. We do not need the kind of backup from day one. We do not want any additional security on day one. We'll actually fix those things when we really require. So we are actually kind of pushing those tasks back because we do not want to spend our time. At the same time, the AWS has the SQL services. I mean, the two popular services are RDS, which actually supports different databases like MySQL, Postgres, MariaDB, MS SQL, and Oracle underneath. And Aurora, which is basically cloud native SQL database, which can scale very high. That supports the Postgres and MySQL. So these are the services which actually hides the overall infrastructure. You are going, it's like you just use database as a service. You select the configurations, you select the database engine, you select the version, allocate your kind of configurations, and then start using it, because it only gives the URL, the endpoint, and rest of the things are configurable. That includes the high availability, that includes the monitoring part, that includes the backup. And most likely, if you are designing something which you are experimenting with, and after some time you do not want to kind of keep it running, then you can actually shut it down, take the snapshot, shut it down, and when you require, you can then again create an instance in few minutes based on the last backup that you are taking. So a lot of the kind of heavy lifting when it comes to the database, because I'm not from the database background, I consider those as a heavy lifting part. I need to kind of go through the documentations, go through the commands, go through the steps to actually set it up. If I do not want to spend my time onto those heavy lifting into the area, I can offload most of those tasks to the dedicated services. Again, as I mentioned, these services are still charged 24/7. So we are not actually saving when it comes to the cost, but yes, we are definitely saving when it comes to the effort. Now, the same database, if we move from the kind of instance-based or host-based database to serverless database, where we are hiding not just the infrastructure, but we are kind of just using it when we have the real uses. That's where we are actually achieving the true agility. When it comes to the serverless database, the AWS has one of the most popular serverless database, that's DynamoDB. It's kind of key value pair database. Almost everyone is familiar with the NoSQL or key value pair database. So this is an internet scale database design. Even Snapchat uses the DynamoDB. And if I just spare 1 second and go by the number, so Snapchat at one point of time was actually executing 1 billion transaction to the DynamoDB in a very short amount of time. It was a kind of a New Year event, and when they actually recently switched to DynamoDB from their existing infrastructure. So this is a truly scalable database, and the very effective part of this is it's fully serverless. You are only paying for the storage, and you are only paying for the query. So that's how actually it is metered. If you are saving the data, it will actually cost you for the storage. Again, this comes with a free tier, but if you are saving a lot of data, you will charge for the overall storage. If you're interacting with the DynamoDB, making the read, making the write, mutations, those kind of requests, you'll be charged for that. So you're only paying, truly paying, when you are actually using the database. And otherwise, if your application is not in use, there is no request to the DynamoDB, you are practically not paying anything. Onto the SQL counterpart, the AWS has been doing a lot of advancements when it comes to serverless. So Aurora serverless is another kind of a serverless database specifically designed for the SQL databases. You can actually use the MySQL and Postgres under the Aurora serverless, and they have recently released the V2 as well. This is also designed for the true serverless. So you make a request to the database, and your database will actually start at that point of time, which is kind of an engineering marvel in itself, that you are running a monolithic database. When you make your query, it will start, it will actually execute the query, and you can actually configure that how long you want to wait before you want to shut down the database if there is no request, and it will wait, monitor, and it will shut down itself. So you have some kind of an use case based application. Let's say you are running for the IoT application. One of your use cases is an IoT application where you need to actually take the weekly and monthly report of some kind, which all of those data are stored into SQL, and you want to actually run the queries on the weekly basis, once in a week and once in a month. When you hit the query, it will actually start up. You can execute the query, get the result, and automatically it will shut down. This way, you are only using your overall SQL database exactly when you need it, and you do not, for this particular use case, let's say you are using it only 4 times in the span of 5 minutes, you are only using it for roughly about 20 minutes in a month. You only will be paying for 20 sort of minutes, and not for the full month. So this the cloud computing is really evolving in this particular direction, where they are creating the services and features which can truly align with the use case. So the RDS and the Aurora are instance-based, which runs continuously, but the counterpart like DynamoDB and Aurora Serverless, which can actually help for the application developers and the architect to actually align the use case and with the right set of service and the feature. At the same time, keeping the overall mindset that I'm consuming what I really need, and I'm actually not continuously running the infrastructure which I don't need, and overall effectively saving onto the operations part and saving onto the cost part as well. And these, because it's a serverless by default natively comes with auto scaling and some of the other things. So this can actually scale from 0 to petabytes in storage, and this can also scale from 0 to many CPUs when the load comes. Next is the file storage. Every application requires to actually store the files in one or another format. Maybe it's your media file, or maybe it's a data file that you are generating. And so by default, when we are developing on our local, even our local system, we actually save the files into our system. Most of the times, we actually forget that those files that we have generated over a period of time, what exactly that we'll do for those files. Are those files are actively used? It's a kind of social media applications. People are uploading the file. Some files are larger in the size, few MBs. Do we really need those files after few days, after few weeks, after few months? So when we actually use the kind of the orthodox or a normal mechanism like the disk to store this kind of dynamic data, we actually lose some of the control, or we need to actually design a secondary solution just to kind of back up those files, remove it out of the main disk. Otherwise, we need to keep on monitoring our disk so that it doesn't run out the disk space, and clean up the file which are actually not required anymore. These are all the heavy lifting part, the additional operational part, because we are using the wrong storage mechanism for the wrong use case. On the other hand, if we talk about the Amazon S3, we saw that it can help into the storage and hosting as well, but it can also it can also help in the intelligent storage access as well. So we are some of the largest social media sites are also actually using Amazon S3 to actually keep all the images. Most popular Amazon.com uses all the images or all the videos that we are seeing on Amazon.com or Amazon.in. All of those are hosted onto the S3. So it's loading those data from there. At the same time, we talk about a particular use case wherein which people are actually uploading the files or images. And after a while, after a few days, after a few weeks, we do not want that to be kind of actively used. We are still paying for the active usage because those files are stored there, saved there. So it will be counted against the overall kind of storage that we are consuming. In some cases, it's negligible, but in some cases, if the files are too big in size, then we are actually paying unnecessarily paying those. In some cases, let's say after 6 months or a year, we don't even want those files. So keeping those files there and manually removing it or running some kind of an additional process to remove, it's an additional kind of a heavy lifting part. Either we need to code for that, or either we need to actually run some kind of a utility to actually identify and clean up those things. S3 by default provides all those features. We have the life cycle rules. We have the different tiering so that we can actually allocate the right kind of accessibility to the right kind of files. We pay for what we use, and at the same time, if we do not want something, we can actually phase it out in a organized manner. So for all the things that we discussed the web part, web hosting part, we discussed the application part, which includes the API and our custom logic. We discussed the authentication part, we discussed the file storage part, and the database part. This is kind of in a single diagram, it actually summarizes everything. The S3 is hosting by default. It's not a file storage; it's an object storage, but it's a kind of a file storage. It is hosting our website, and the user is downloading or opening the website into the browser. Then the user is directly kind of interacting with the Cognito that I'll show in the demo as well. User is directly interacting with the Cognito for the authentication and identity purpose. Once that part is done, now our user is authenticated, and it can actually invoke the actual APIs, which will maybe save some of the data to the database or load some of the data from the database and display here. The entire, all the parts, all the services, all the things that we are using here, everything is serverless. If we are making a use, then only it will be used. Otherwise, it is just sitting idle. We do not have any active infrastructure with it, which we need to maintain. We do not have any instances which are running, and we need to see that for how long it is running, or if at all people are using it or not. This is kind of the advantage of using the cloud services, where we are effectively using the right service to actually carry out the right task. At the same time, we are kind of getting the value return that we get is that the agility, because we are just bringing all of these services together and just focusing on to the custom logic. Let's say our algorithm is the main part, then we are just focusing on the business logic into the compute part. Everything else is just kind of a repetitive things that we are integrating and just using it. We are not basically coding for the authentication. We are not basically coding that how we will actually upload a 1 GB of file. It's a task in itself. If any of you have designed an application wherein which in a virtual machine base, you want your user to upload a 1 GB or 2 GB file or download such a large file. In most cases, if you are in the development, it will actually crash your server one or another because you have not designed your application to actually take that much amount of load. You are simply testing with a very simple files, and I do that as well. But offloading those kind of tasks to the service, this external purpose-built services that we know that what we are doing, they are designed for that. They are designed for the scale. They are designed for the load. This is slightly kind of an expanded version in which the different few other services are also integrated. The flow is still the same. Client is my browser. I am using the CloudFront is basically a CDN. Consider that as a CDN to actually fast load or cache your HTML, CSS, JavaScript. S3 is the place where you are saving all the source code related to the web part, only the web part. Then it comes back, and then you interact first with the Lambda. In this case, here we are using the third-party identity provider, so I'm signing in via the Google, Facebook. Once they return the token, that means my identity is kind of validated and I have received a successful OAuth token. Then only I'm actually able to kind of access the API gateway, and that token will still be verified via this custom logic. So all these blocks are the place where the code is residing. Everything else is nothing but the different services that we have offloaded our entire the requirement. So API gateway then executes the particular, like this is an example, /ticket. So that's my endpoint, and I want to execute whatever logic that I have written for the loading the tickets from the DynamoDB. So that is here. For the shows, it is using the caching mechanism. So either it will load it from the cache or it will load it from the table. And the info is static. So I can actually customize the overall application flow. So depending on where the information is stored, I can actually design the logic so that it only points to that service. Now, one simple thing that you see here is that because everything is kind of broken down into individual pieces, cloud providers takes the security as very critical thing, because that's why they call public cloud provider. We are not the only people that are hosting our services. There are many organizations hosting their mission critical or business critical applications into the same environment, same data centers, as we are also hosting our simple or experimental application or our personal application. So it's basically it's a data center which is hosting all of these customers application at the same place. So they need to make sure that everything that they do is completely secure, completely isolated, and then there is no conflict. I should not be able to actually interfere in any other workload, and their workload should not interfere in mine. It's a very complicated engineering stuff that goes behind that. But as a developer, what we get as an advantage is that now we can actually design our application where whatever that we write, that we have the full control that what kind of a permission Okay, what kind of a security features or accessibility of the other services that we want to actually give to our code. Now, there are many libraries, and you may have heard that in the past. There are many libraries that actually work as a Trojan, and then the developer community from time to time have actually shared that as well. So some of the libraries, very popular libraries, can actually those kind of things. Now, whatever code that we are executing here, we have the ability to that we assign the right permission to that code. So that code is running whenever it is executing. It has only certain set of access point. It is still not, most likely still not aware about the overall infrastructure that I'm running as a kind of a full scale application. So with the use of IAM and the policy and the rules, the AWS with the Lambda, we can actually design the application which does one task, and we only allocate the required permission to that particular code. Least privilege is basically the word that we actually refer. So we are isolating, we are breaking down our entire application into smaller chunks, microservices, the functions, and we are allocating the right resources to the functions. And the function carry their own permission so that it only actually interact with the services it should, and nothing other than that. How so far we actually mapped from the service to the service, and we actually saw that what exactly is my normal selection and what exactly that I should use instead, so that I can only focusing onto the code and not onto the other part. But how this can evolve now, if you have seen, then what we are doing is we are actually guiding the flow from one place to another place. So I'm actually putting the front end code into the S3, downloading it from there. I'm then actually making the direct request to the cognito so that I can authorize or validate the identity, the username and password. And then I'm making the call to the API, and then API is dispatching the request to the Lambda. Lambda executes, fetch the data from the dynamic DB, return it back, and then returns. All of this internally works as an event. So the everything, or I'll not say everything is always event driven, but most of these things are basically event driven. Events are emitted or events are dispatched, and another service actually picks up the event, execute the code, and then return the data, whatever it is supposed to. So the same example as we saw, that S3 is loading the code into the front end code into the browser, then it makes a request to the API gateway. Now, API gateway is basically a cutoff. It is only accepting the HTTP request, but it's not executing that. What it is doing is that it knows that it has configured function with the request. So it is whatever the incoming request has come, it is executing the Lambda. If you are making the post request, then the body will be passed on to the Lambda. If you are making the GET request, you can actually still parse it and send the query string and the parameter in the Lambda as a body. Lambda will execute that code and will return it back, and then it will come back. So internally, the overall chain is nothing but a combination of events that flow from one place to another place. Now, if we look at from the overall application point of view, because we are not doing only one task, there might be many features. We have the in case of, let's say, in the case of a e-commerce based application, we are showing the catalog, we are taking in the cart, then we are actually redirecting it to the payment. Once we receive the payment or order confirmation, then we actually go for the logistic dispatch and stuff like that. So these are different microservices, functional division of the application. And in a way, we can actually divert, we can actually do the communication via the events so that everything can work and run on its own. And when the event comes, it will actually execute the task. Now, the advantage of this is there is no direct dependency. Everything, all the tasks are carried out via the events. So there is no endpoint to endpoint. We do not need to at some point of time, if something fails, and things do fail, if something fails, we can still have collected that as an event, and we can actually execute that particular part later on. And that particular failure, let's say our payment part is failing, our payment logic is failing, but that will not actually fail the rest of the application. The rest of the application will still work, only the payment part which is having the issue. So that's called event-driven architecture, in which the events are basically carrying out the command or what needs to be done, and the services or the functions, the logic is basically capturing those events and executing logic. It's the event-driven and the serverless is kind of synonymous in this case, because the serverless by default waits or executes the task based on the events that are received. So some of the services that we saw, right, from the web application point of view. So Amazon Cognito auth service, it actually emits the auth related events. So it can be consumed and it can be customized as well. API gateway emits the HTTP events, so that based on the HTTP request, we can execute the code. Lambda can emit the success and failure event. This is basically chaining the Lambda function. If you do not want to write and that's the another kind of rule of writing the kind of evolvable or extendable application, is that you do not write a different logic in a one function. So you actually create the function which carry their own logic, so that you can actually utilize this function, or you can actually extend the function. So Lambda can execute and then based on the success execution or failure execution, it can emit the event, and we can do chaining and execute something else. S3 as a storage, it emits the files operation related. So if a new file arrives, it actually can emit the event. If the file is updated, it can emit the event. If the file is kind of deleted, it can emit the event. DynamoDB, if you are making the database related operation, it can actually emit that a new entry has been made or updated or deleted. Now, what this helps is basically in the decoupling. We are not tying down, or we are not hard coding the entire logic. All we are doing is we are carrying out one task. We are, let's say, we are writing the order has received, or order confirmation has received. We are writing an entry, and then that part actually triggers or generates an event, and that way we can actually call another microservice, and it will carry out the rest of things, whether the payment has been collected or the payment has been authorized, and stuff like that. Once that part is done, we actually send out to maybe logistics system can pick it up. Once that is kind of a packaged and dispatched, it will generate another event that this particular order shipment has been kind of dispatched, and the dispatch system will pick it up and send out the notification to the user. So Amazon does this thing at scale, and they follow the event-driven architecture or asynchronous execution at scale, because they are into the business where they are actually doing millions of transactions per second. If everything is dependent on each other, something if one service fails, it will have a domino effect, and everything else will start failing. That's why they actually employ this kind of an architecture which can independently run and execute, and then just based on the events they receive, it actually executes the task. So far we have seen the kind of required areas from the server, storage, authentication. But what about the optional targets? How do we achieve the other part? What exactly is the value that we are getting out of it? So because we are hiding the infrastructure, we are not interacting with the infrastructure, or the service is not giving the visibility of the infrastructure. Some of these things are kind of secure because it has very low kind of visibility, low blast radius. Plus, as I mentioned, we cannot go inside the S3. There is no way to actually go inside the S3 and see what's happening. Same way, Lambda API gateway, we cannot log in or SSH into that. It is provided as a service, so we just consume that service. By default, serverless, because there is no server, there is no configuration of that sort. So it's by default scalable. The scaling is maintained, managed by the AWS itself. We do not need to do anything. High availability is also comes by default, because we are not selecting. In a virtual machine base, your virtual machine runs at one place. That's a central point of everything. If that machine goes down, everything goes down. If that machine is up, things are working. In this case, we are just using the service, and service takes care of where and how it actually runs everything underneath. So it is designed for failure as well. So if AWS realize that some part of their service is failing in one kind of a data center, it will actually switch over to using a different data center. At the same time, cost effective, because we are only focusing on the features that we want. We are using the service for that, and all of these services are basically charging metered based on the usage and tailor-made for that kind of usage. We are using the S3 where it is actually charging for the storage and the interaction. We are using the API gateway where it is metered for how many requests that we make. We are using the Lambda where it is metered for how much time that we spend processing the request, and everything else is just kind of otherwise it is just waiting for the request to come. Now, how we can actually employ the same thing to the mobile app as a backend. So some of the same things will carry forward, like I said, in a web application, in a mobile application. The important thing that actually changes is the interaction with the system. So most of the heavy lifting that you do on the mobile side, but you interact with the backend via the APIs. So it's the same example. Again, we are using third-party identity provider, which for the identity validation. Then we are using the API gateway to actually execute our API request, and underneath it actually uses the different services. Now, I saw one of the use case which is related to the IoT data as well. So almost a lot of people are familiar with this automated or robo vacuum cleaner, that is iRobot from Roomba from iRobot. Interestingly, that's one of the very first or early adopter of serverless technology. They saw a big value because they have this thousands of Roomba vacuum cleaners in household across the globe, and they wanted some kind of an elastic and a natural architecture which can actually grow and shrink depending on the demand they have. And they don't want to they didn't want to actually spend a lot of time, effort, energy onto maintaining that infrastructure, and focus onto the engineering part, that is the vacuum cleaning. Their business is around designing the modern vacuum cleaners. So they actually re-architected their application and made it serverless. And when it comes to the IoT in AWS has a lot of services which actually specifically targeted for IoT. So here it is showing the same thing. Now, that doesn't mean that you cannot actually integrate the IoT with, let's say, API gateway or even the virtual machine. But the IoT applications tend to because those are device where it tends to actually shift the load. I have seen in past some of the use cases where the people or the company, they actually contact me and ask me that we have hit some kind of an issues, right? And we are not going to see a lot of kind of demand, but we have an infrastructure which is kind of over provisioned. So do you suggest that we shrink it down? That's one way of looking at it. In some cases, if the business is going good and they are doubling on the number of devices suddenly in a small amount of time, they need to actually make sure that the infrastructure is scalable enough, that every device has the availability, because your IoT devices are available only if it is designed that way, if you have the backend connectivity accordingly. So IoT applications are overall, it's a very good fit for a kind of a scalable serverless architecture, because you do not know when your demand will grow and shrink, and at the same time you do not want to keep a very high infrastructure kind of a ready to serve the request. So this is taken from the case study of iRobot. I have actually put the link as well, where they have the companion app where they configure everything. Again, it uses the standard set of services. It uses the Cognito for the authentication authorization, and then it actually connects to an MQTT broker, which is nothing but another kind of an API proxy or a gateway. And there, it actually emits all the IoT data. Now, along that, you have the additional services like IoT rule and shadow devices, where you can actually then execute the custom logic. So if you want to based on the data, if you want to actually generate the alerts, send out the notifications, or do some kind of analytics, this can be kind of done very easily, because the events are actually flowing from one place to another place. And IoT is a prime example of event driven, because they emit only the payload when of their particular use case. So it can be customized, it can be extended in a variety of ways as well, instead of writing a full kind of a virtual machine based solution. So now, the one thing that people ask that if everything is hidden, if I'm using just the services and I don't know what is going on, how do I monitor? How do I monitor everything? How do I make sure that everything is running? Right? That comes as a kind of a natural, right? If the internal part, if I cannot see the terminal of my code, how will I know that whether it is running or not? How, if something goes wrong, if the error comes, how do I know that what error has come? So that's where the AWS has the management and the additional tools, which can be used for a variety of ways, not just for the logging, but even for the other tasks. We can actually process the logs, we can identify, extract the important information metrics as well, and to make kind of a overall guess that what is going on, whether our application is used or not used. Because sometimes in a host based, even a virtual machine based application, if you're not installing the monitoring and other tools, if someone asks that are your application in use, it's very difficult for you to tell that yes, it is in use. You need to go inside, maybe use their database, or maybe use something else to actually figure it out, that how many people used it in last few days or last few hours. On the other hand, on the other side, if you are using the managed or the serverless services, the visibility is right there, because all the other things are hidden and visibility is kind of externally provided by the AWS itself. Even event-driven architecture, it's very easy to actually lose the control. If you see, all of these events are flowing from one place to another place, and I'm executing the task. Now, if I want to actually carry out a specific task and there are different steps, how do I actually do that? Whether I write all those steps at one place, or I still kind of orchestrate different events to do that. And if the event is lost, if for some reason there is an error or something like that, and if it is lost in between, how do I know that I executed that particular flow in full or not? And almost every application has some kind of a flow where you have the set of if-else conditions or set of loop that you want to actually go through before you can actually end that particular flow. So AWS has another very powerful kind of a flow execution service, a step function. This helps in the orchestration, and this can be used in a variety of ways. I'm just putting a very simple example because it's good to know. And this service can actually very well fit into some of the use cases that you are targeting, especially the scheduler and the execution task execution use case from AWS. This is the service that actually right suitable to that. Again, this is also fully serverless and managed. You are only paying if you are actually executing or using that. You are not paying anything if you are not using it. And as you are seeing the screenshot, this is a flow. A flow is designed in a kind of a JSON language, but ultimately you are internally telling that what function to execute and how the function should be executed one after another. This is kind of a simple example to that. I am receiving a request. In my Lambda, I am actually then starting the workflow or my business logic. Internally, it actually calls different Lambda one after another. This is basically a booking example. So internally, it calls many different Lambdas. All of these boxes are nothing but different code functions that I've actually split into multiple smaller functions. And they are orchestrated because this is the overall flow. When I execute this, it has to, one or another way, it has to actually traverse through this path. This is the way I'm achieving the control, that even though everything is distributed, everything is event driven, but I can still actually control and put together all of these pieces in one block. Now, so far we have seen most of the slide. Now I want to actually quickly go through kind of sample application that I built last year for a different workshop that is also fully serverless. I'm taking an example of a serverless web application which actually helps to store the files, that is the user files in a secure manner. And towards the end of this, I'll actually explain that how I'm doing that. So this is my application. This is I'm using the serverless framework. This application is using the same services that we have gone through. It uses the S3, it uses the Cognito, it uses the Lambda, and other things to actually carry out the task. So let's up. Now, because I'm using the a framework like serverless framework, internally what it does is it actually uses the kind of infrastructure as a code mechanism, and cloud formation is one of that. So cloud formation, you can actually kind of create your entire infrastructure script in JSON format, and then when you execute that, it actually creates all the resources. So by resources, we S3 bucket, S3 has buckets, so that is a resource. Cognito, you require to actually create the kind of a user pool, so that is another resource. Then you have the Lambda function, which is the function definition and the source code and the other configuration that you need to provide. That is also again a kind of a resource. So all of those things, it actually internally creates and set up the whole environment. So I've already deployed that. The code is here. I'll also put the link into the description. It's a public code. All I have done is I have actually cloned it and deployed that. The source code related to the front end is separate. Like as I mentioned, the web part I'm actually keeping separate. Separate. I'm hosting that on S3, and the back end is separate. So if we go here, this is basically loading the this page from the S3 bucket. I can show the bucket as well. So it will be easier to actually. So this is the deployment bucket. Is hosting my, yeah, this one is having the HTML, CSS, and JavaScript. So this is all my front end code. I have the JS file, I have the CSS, and I have the HTML that I'm loading into the browser. So it is coming from there, and that's why it is this kind of a URL. Now, the Cognito, I can actually also check. And the Cognito is a place where we have the user information. So in this case, I'm not writing any of the custom logic. So I don't have my own database to actually save the user information and stuff like that. I'm offloading that to Cognito. If I go to Cognito, Cognito can show you that how many users and how many the other that you have. In this case, what I've done is I already have a user. That's myself. What I'll do is I'll actually remove this. Right now, this particular application has no user. What I'll do is I actually create a user myself. So I have kept the inspect open for one reason. If we see, all the information are actually redirected to specific services. So I'm making a request against the Cognito IDP, that is the endpoint for the Cognito in US East 1 region. So this particular code is directly making the request to the service. It's not actually executing. There is no server. I'll come to that part, but there is no actual server. This web page is loaded from the S3. As we can see here, this HTML is loaded from the S3 and all the assets after that. And then when I'm actually registering myself, it is executing that request directly against the Cognito service. So there is no kind of a virtual machine, or there is not even the Lambda function that is required at this point. I'm just directly accessing, executing against that. Now it has sent me the verification. So Cognito comes with a lot of the default configuration set. This one has generated kind of verification code. I'm verifying that. Now I'm ready to actually log in. Now I'll show you one thing. Now I have purposefully this particular application, because we are actually storing the secure file. I have enabled the two-factor authentication. Now I have not written any code. This is part of the configuration that I've given, that I've told to Cognito, that the MFA is required. Whoever is kind of logging in or registering, they should have the MFA enabled and they need to configure it. So all of those tasks, which may look kind of a very important, but now it's very trivialized because it's the part of the overall the identity service, right? You are not just logging in with the username and password. There are many other things as well. So that is also captured inside the same service. And I've just simply provided the configuration that whoever is registering must also register the MFA, and then only they can actually successfully log in. So based on the response, the UI application is saying that the Cognito will not allow me to actually resume the login because I don't have the MFA set up. So what I'm going to do is I'm actually going to set up this MFA. I'm using the Authi app to actually create. Six digit and save. It will generate this code, which I will copy and paste here. All of this code, if you see closely, it is all firing against the same service. There is still no kind of a custom logic or custom code executed anywhere. I've logged in, and this time, because the kind of MFA is set up, now it is asking for the MFA code. So I'll just simply copy this. Now, this is my simple, this is just for the demo purpose that I've created to illustrate the different services that we can actually bring together. And the thing is, this is a fully functional kind of a file storage service. You can actually upload the file, you can download the file, you can share the file and stuff like that. This has very minimal or almost zero actual logic. All of this is done by using different services. Now, if you see one thing, after the Cognito part is over, now I'm firing the query directly against S3. I'm actually querying how many files I have in my account. So because I just signed up, I don't have any file. I can actually upload. I can file. It will actually also upload the file directly. There is no compute link. So the idea is that there are so many powerful services which are purpose-built for something very specific. We can use that. This not only minimizes the effort, that the additional code that we need to write and maintain, it also actually improves the overall resiliency of the applications, availability of the applications, and the security of the application as well. Now, internally, this actually creates kind of a separate bucket and folder inside the S3 and stores all of my file there. This is a very simple. I'm going to actually, we are almost at the timeline. So I'm going to, so this is the source code. If you actually download and check the source code, it looks like that. And I'll show just one thing. I am actually using, these are the different permissions that I have given. What I have done is it's different. This also carries the infrastructure as a code part. So all the necessary resources that are required for the overall application. So for this one, I need the hosting bucket. I need another bucket to actually save all the files. I need the Cognito so that it can, with a configuration like that, the MFA has to be enabled and stuff like that. So that is also configured. And it is also actually putting the right permission so that only the people who have uploaded their file, only they can actually see their file. So no one else can see their file, and that is actually done at the identity or the policy level. So some of those things I will, because of the time, but I'll not go through right now. But this is the overall application. You can actually go and check it out. I have actually put kind of a slightly different documentation. The link and other things are also in the same presentation, which I'll share. This is just to demonstrate the power that we can actually use this multitude of services and can still focus on the overall use case. My use case is to design a kind of a web application to actually store the files. But for that, I don't need to actually design the whole application. I wanted the user authentication, I wanted the MFA, I wanted the many other things, but I didn't actually code any of those things. I just used the existing services and fit my overall use case around that. This has some vendor locking. Some people will say that this is tied to the infrastructure, but the lock-in itself is available one or the other way. Whether you design your application against the services or you design your applications in a different manner. Lock-in is still exists in one or another way. So some of the dev tools that I'll actually recommend and suggest if you are actually going in this particular route, serverless framework or SAM, very easy to actually learn and adopt, and even you can actually shift. Many of you might be have already developed the solution and might be thinking whether you should go that route or not. But just give this services a look. Look at the tools and the framework. Some of the service and the tool itself are easy to migrate. You can actually shift your code from one place to another place. And like I said, the Lambda actually supports half a dozen languages, including the container. So you, in cases, it is possible that you can actually shift your code from existing to that. CloudWatch for the logging and monitoring, so you can see what's going on. If there are specific errors or something like that is coming, then you can actually use the X-ray. And then budget is something that I usually recommend that you first make sure that you have a budget set so that you are not over utilizing. You forget to actually turn off the server and you actually created a higher configuration instance for the database or something like that. And then you realize that you are paying for the infrastructure which you are still developing or nobody's using it. So that's the one of the reason why I actually prefer that budget and something like that is you set upfront. Just to wrap up, I'll start with a line from the Werner, Dr. Werner Vogel. So he popularly, so AWS is like the leader in the overall cloud computing and infrastructure space. AWS is also leader in the serverless space. And when they introduced that, and now every year when they release new services, many of these services are oriented towards the serverless or a managed service, so that the developers or the builders can focus on building the innovative solution and kind of not paying a lot of attention to the underlying infrastructure. No server is easier to manage than no server. So that's kind of a philosophy that a lot of the newer services are following. And one interesting thing which I actually not mentioned here, but Amazon.com, so that is the parent company. So just in December, the CEO of AWS actually, when one of the largest event, he actually revealed the number that almost half of the new applications that they design in Amazon.com uses Lambda. So that is, they are using the ephemeral, they are using the serverless compute, Lambda, to actually design, develop 50% of the newer application inside the Amazon.com. Now, Amazon.com actually runs thousands of mini, micro, or major applications, and it's a bold, a big kind of a number. It's kind of proves itself that the service and the maturity level of the managed or the serverless services that the one of the largest company in the world designs majority of their applications using this way. AWS has services for every possible use case. Cloud is powerful, but we need to still use it. I mean, it provides a lot of services and options. for different use cases. If our use case is simple, we should start with simple. If our use case grows complicated, yes, we should adapt to that thing. Own less and build more. Kind of just shift the focus on to what is the differentiator part, what exactly is required out of the solution, instead of paying or spending time or effort into the kind of undifferentiated heavy lifting part. Authentication is still authentication in a database. To me, it's a very simple example. Event-driven systems can evolve. If you are designing your system which actually uses the events to carry out the task, you will find it much easier to actually evolve, extend, and carry out the different things. Again, experiment and learn, and that's what this is all about. Some of the references, and with that, I am still well within the time range. So thank to the Crio and all of you. If there are any questions, I don't see the questions here, but if any of you have any questions, if there is any way that I can see the question, I'm happy to answer. Oops. I'll still wait.